Hello, 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 hello. Hello, 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 hello. Hello, 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 hello. So yeah, hi everyone. This is Devansh here, and today we are going to basically discuss all the problems of today's Leetcode Biweekly Contest. So today we are going to discuss four problems. Do comment out how many problems you guys did. So yeah. Also, yeah, if you have any doubt regarding anything while I'm explaining, you can ping it out in the comments. I will be actively watching comments. So yeah, today's contest is easy compared to previous contest. Yeah, today's contest was easy. It was pretty standard contest till the third question, and the fourth question was also pretty standard. Like more of algorithmic contest, nothing, not on the creative side. So someone did four questions, someone did, yeah, very great dude, and someone did three, and then again someone did four and three. Yeah, great guys, great. You guys did really great. You can also ping out like if you think you had some better solution, or you think uh, like you want to add some observation or intuition, and someone did three questions. Great, dude, great. Do ping out how many questions you did solve today. Great. So majority solved around four to three here. It's okay if you did like even one or two questions. It's fine. So yeah. So this was today's contest. We had four questions. The first one was easy, and the next two were medium, and the last one was the hard one. Yeah, so we had like easy, medium, and then hard. So yeah, this was actually again, yeah, this was much more. All the questions were not on that much on the creative end, rather just implementation and or proof of problems. That's what I felt actually about the contest. What you guys felt, do comment out, and then also let's start discussing the problems. Okay, okay, let's start from the very first problem. So how are we going to discuss the problem? First we are going to read the problem, and first we are going to discuss like what we could get from this page, or what we could get from the problem statement itself. And we are basically going to develop our understanding of the problem itself. And while developing that understanding, we are going to write out every intuition that we are getting from it, and every observation we get. And then we are also going to discuss the examples. And once we are done with developing the understanding of the problem, we are going to solve it. We are going to move toward the solution, right? That's how we are going to discuss problems today. Solve three today, three. Yeah, it's fine, it's fine, it's great. Great, great, great. So yeah, let's start with the very first question of the bi-weekly contest 176. So the very first question is weighted word mapping. Okay, so you are given a array of string words where each the word containing lowercase English letters. You're also given an integer array weight of length 26 where weight I represents the weight of ith lowercase English letter. Okay, okay. The weight of a word is defined as the sum of weights of its characters. Okay. For each word, take its weights modulo 26 and map the result to a lowercase English letter using reverse alphabetical order. Okay. That means that 0 is Z, 1 is Y, and we go on, and 25 A is 25. Okay. Return a string formed by concatenating these mapped characters for all words in the order. Okay, great, great, great. So yeah, this is the very first problem. So what we got of the problem is, the first point we got is, we are given this array of words. This is array of strings, right? What does this mean that this is array of strings? That means that this is an array and it will have some string like this or this x, y, z, right? Dot, 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 dot. Like this is the array of string. This is the first thing we are given. The second thing we are given is, we are given that uh, we have this weights array too. Okay, we have this weights array where its size is actually 26, and for each corresponding index, for index 0, this index tells the weight of the letter A, and this is some number. For example, it could be 4, it could be 5, it could be 1, right? And similarly for index 1 tells us about the weight of B, and it could be again, this could be 3, 7, it could be any number, right? These can be integers. So what this tells us? This tells us weight of character. This tells us we have this weight array which tells us the weight of each character. Okay, great, 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 good to go. Now third point, what we got from the problem is that the weight of a word is sum of weight of its character. Great, got it. Weight of a word is sum of its characters, sum of weight of its characters, sum of weight of its characters. Okay, great. And what is the fourth thing we are given? We are given that each word, after like here we were given a array, array of strings, words, where we are given different words. Okay, great. And then we are told some operation or some sequence of operation, that we have to take one word. We have to take this. For example, let's say we have this word, and we have to calculate its weight. How are we going to calculate its weight? We are already given here, right? And after calculating its weight, we are going to modulo it by 26 and then map it to a character. To a character, right? This is an implementation problem. So basically, here we are actually given what to do with this words array, and this is our actually question too, right? And map it to a character, and basically for each word or each string in the words array, this will map to a character, right? This will map to a character and then print the character in the sequence. Hope that's clear. And this was our fifth point, that return a string, that we have to return a string of characters that we got. Let me So this is our entire question. This is what we got from the question, right? We are basically given a words array of strings where each index we are given a different string. And then we are told that we are also given a weights array. And what does weights array tell? It tells us that at each index corresponds to a character. Its zeroth index corresponds to the very first character, and we are given a weight of that character. And similarly, each character has its weight, right? This weights array tells us that what is the weight of that particular character. And after that, we are given that what is the weight of a word. Word is basically a string, right? The weight of a string is weight of character is also already given. So weight of string is sum of weight of its characters. Great. And then what we are told, this is our question, is that we have to basically convert each word given in the words array we have to basically convert it to its weight, and then we will have some weight, right? Each word is a string, right? From that string we have to get its weight, and that weight we need to modulate by 26 and map it to a character. And how are we going to map it? We are given that the number 0 is going to map with z. We are going to map it in reverse order, right? Even though Z is the last character of the alphabet, we are going to map it to the 0. Even though Z is the last character of the alphabet. And 1 is going to be mapped with letter Y. And similarly, 2 is going to be mapped with the letter X. And we are going to go on, and such that the number 25 is going to be mapped with the letter A. Right. So this is the entire question we are given. And this is the classic like lead code easy, like is the very first problem of the lead code. So basically after we are, it doesn't have any like riddles and all. We just, it's just an implementation problem. It's on the easy side. That's what I meant to say. So this is the entire question. Let's also discuss a example. Let's also see an example here. So this is what we are given as an input. Okay, great. Let's so let's go here. Yeah, here we go. So this is our words array. Words, right? So this is our words array of strings, and this is weights corresponding to each character. Great, great, great. So what we need to do, we have to basically return a string, right? Return a string. What we have to return a string, and what is this string going to be? This string is going to be how are we going to get this string? We are going to get this string from this words array. So what we need to do, we have to for each word, or we have to take each word, we have to convert, we have to get its weight, and we have to modulo it by 26 and then map it to a character. And after mapping each word, this entire string will give us a word. Let's say this entire string will give us a character. Let this character be s x. This will also give us a character. This would be, let's assume it is y. And after this will also going to give us a character. This would be z. And then we are going to take this array of characters. What is array of characters? A string, and we are going to print x, y, z. Right. Okay, let's go word by word, right? Our first word is ABCD. What is going to be its sum, right? What is going to be its sum? First, let's go step by step, right? What we need to do? First, we need to convert it into its weight. How are we going to get weight of a string? We are already given here. The weight of a word or a string is sum of weight of its characters. Okay, great. So, thus weight, I'm going to denote the weight by W, okay? For easygoing. So weight of this string, just one. Yeah. So the weight of this string would be weight of the character A plus weight of the character B plus weight of the character C and the weight of the character D. Right. What's the weight of character A? How are we going to get the weight of each character? We are already given the weight of each character in the weights array. And we are given that the zeroth index is going to give us the weight of the character A, the very first character. And it's going to go in that sequence. Thus, this index, the one index is going to give us the weight for the character B. Right? So what's the character weight of the very first character, the character A? It's 5. And what's the weight of character B? It's 3. And what's the weight of character C? It's this index is going to give us the weight of character C, right? So it's 12. And what's the weight of character D? It's 14. And we finally make the sum of it. What's its sum? 14 plus 12 is 26, 26 plus 3, 29, and 34. Right. So we got the weight of the word. And what we need to do was the next step. The next step is to modulate by 26. Okay. Okay. So, yeah, we are going to modulate by 26. The answer is 4 plus 4 is 8. And then someone commented that, yeah, Fenwick trees, yeah, today's fourth problem I think you are talking about. Like I did it with segment trees, but yeah, I think Fenwick would also work. Yeah, again, going for the same problem. So we are going to basically follow the step by step. So the second step is to modulate by 26. We got 8. And then we have to map it, right? What's the map of it? Right, we are given we have to map it in the reverse order. Okay, let's see what's the reverse order, how this reverse order would work. For 2, this would be x, and then we have 3, 4, 5, 6, 7, and 8. Right, we want to map it with the 8th character in this map. What would it be? This would be R here. Right, and this would be, I think, as T U V W. Right, R S T U W X Y Z. Yeah, great. So this would be area. So we are going to map it with R. For this character, what we got? We got the character R, and we are going to store it in our answer string. Our answer string would be equal to R. Right. So this we did it with the first word, and we are going to do the same operation, same sequence of operation with both words. The second word is DEF. Okay. And finally, we will get a string that we have to return. That would be our answer. This is like pretty straightforward. So we have this DEF. What would be its weight? Its weight would be weight of the character D plus weight of the character E plus weight of the character F. Right? What is the weight of character D? Let's see. So this was C. So this is D. This would be E and this would be F. So this is 14, 1 and 2. So we have 14 plus 1 plus 2. So this would be 17. And what 17 modulo 26? It's 17 itself. So we are going to map it with the 17th word that we get. Right. The 17th word that we get, right? And the 17th word is I. So we get here the character I. Okay, got it. So here we got character R and here we got character I. Let's also go for X, Y, Z. So the third word is X, Y, Z. So we need a weight of X plus weight of Y plus weight of Z. Right. So the weight of X, Y, Z is last three words, right? So X would be 7. This would be also Y is also 7, and this is Z. So that would be 7 plus 7 plus 2. So this would be 14 plus 2 is equal to 16. And 16 would point to J. Right. You can actually make this table and easily, visualize it if you are not getting it. But this is the entire procedure. And after getting these three characters, we get one character from each, and then we are going to return this string that we got after, from each character. The string would become R, I, and J. Let's take our answer. So yeah, Rij is our answer. Great. Here you can also see, right, the weight of character ABCD is 5 plus 3 plus 12 plus 14. This 5 is the weight of this character A, 3 is the weight of B character, 12 is weight of C character, the character C, and 14 is weight of the character D. Thus, the weight of this word is actually 34. Sum of each individual character in ABCD. Right, right. And then we are going to return this string that we got after extracting it. Let's also see the input and output constraint. So the number of words we would have would be 100 and the length of each word is 10. Okay, great. And the length of weights is 26 for obvious reasons, because how many letters we have in our alphabet? 26. And weight of each would be around 1 to 100. Okay, so these are our constraints, pretty low constraints, right? So, like, after reading the problem, right, let's go step by step. What should we first discuss? First, we should always discuss the brute force solution, right? Right. Whenever you encounter any problem, always discuss the brute force solution first, right? Because the property about brute force is it would always work, but it might not be optimizable. But here, as our constraints are pretty low, right? We could just implement it straight away, right? We could just implement it straight away. What we need to do, we could iterate each string. Let's say we are iterating the words array. First we will reach out to this string, right? And then for each character we are going to iterate for each character, and then for each character we are going to find the weight, and in this way we are going to calculate it's the weight of this word. And then we are going to go by the procedure. First we are going to modulo this weight by 26, and then we are going to, the number we get, we are going to map it with the character that we are going to get, right? And using this, for each word we are going to get a character, right? And then we are going to just combine each character that we got from each word, right? So it's brute force is pretty easy and like pretty standard, right? It's already given in the problem. You don't have to do that much else. Let me also read the question comments. Yeah, and even then fourth question. We are going to discuss the fourth question. Don't, no worries, right? So yeah, so that's the brute force approach. That's already given, right? So basically, iterate all words, and then calculate the sum. Calculate sum of word, and then modulo this sum by 26, and then map it, or push the corresponding character. Push the corresponding character to the array or whatever you are doing to store the characters that we got from each word. Let me also show you the code for the same. So yeah, here it is. How are we doing it, right? So let me explain it. You will get the links for your submission, and the submission links you will get, that would be much more better version of these. These are the version that we wrote in the contest itself, but you will get much more better commented version. So what I did was, the first thing I did was, for in this loop I'm storing the weights corresponding to each character, right? For each I made two maps. This w map is going to basically store the weight corresponding to each character. How is it going to store? This is going to basically, for each character, I am going to check its weight in the weights array that we are given. Right, we are given two array. One is the array of strings or vector of strings, and other is array of integers, the weights array, right? So this map is basically storing the weight corresponding to each character, and this map is going to basically store this map. The MP map is basically storing the character that we are going to need here, that the character that we are going to map the number with, right? This 8 needs to be mapped with the letter R. How are we going to map it? We are going to keep this entire dictionary that is going to basically give us the character corresponding to each integer. This entire dictionary is stored in the MP uh, dictionary or map. As I'm using C++, we have maps here, right? So here it is. Hope this is visible. Yeah. So here we are basically keeping a, one second just, yeah. So here we are basically storing the character we will get for each number from 0 to 25, right? And here we are storing the weight corresponding to each character, and then this is our answer string that we are going to return. And then we are basically iterating each word, and for each word again we are iterating each character and getting its sum. We are basically adding, in this sum variable we are adding the weight corresponding to each character in the string. And for for this sum, once we calculate this sum, we are basically going to modulo it by 26, and then we are going to push the character corresponding to the sum or to the number in the answer, uh, in the answer string, and then we are going to return this answer string. Hope this was clear. This was like pretty easy problem, pretty standard and easy. Hope everyone solved it. If you guys have any doubt regarding the problem, you can also ping it out in the comment section. I would be actively seeing the comments even after the stream. So yeah, this was the entire question and this was the entire solution. Let's move to the next question. Yeah, let me also read the comments. Okay, let's move to the next question. Yeah. So the next question is the medium one, and now let's read it. So the name of question is number of prefix connected groups. Okay. So you are given an array of string words and an integer k. Okay, great. So what we are given? An array of string words, right? So we are given this words, which is again an array of string. So it would be like this, a b, something like this, right? Dot dot dot. And then we are also given an integer k. Okay, great. So two words A and B at distant indices are prefix connected if A 0 to k minus 1 is equal to B 0 to k minus 1. Okay, great. So we are given this variable k, and then we are told, let's say we have two strings. We have two strings. One of them is A and one of them is B. They are prefix connected. Prefix connected. They are prefix connected if we are given that from 0 to the index k minus 1, right, is equal to in the is equal to 0 to k minus 1. What does this mean? The prefix is same for both strings a and b, right? Prefix of length k is same for both. Then they are called prefix connected, right? Two strings are called prefix connected if their prefix of length k is same for both. Let's take also an example. Let's say we have this string abcd and we have a string abxx, and let's assume k equal to 2. The prefix of length 2 of a would be ab, right? And the prefix of length 2 of b would be ab. So these two are prefix connected, right? So this is what we are given. And the fourth point is a connected group is a set of words such that each pair of words is prefix connected. Great, great, great. So the fourth point we are given about connected group. Connected group, each pair of strings is prefix connected. Got it? So basically, return the number of connected groups that contain at least two words and formed from the given words. Okay, great, great, great. So what we are told is basically, so what we are told is basically, this is the entire question. Then at last we have to return number of groups. Groups with size greater than 2. With size greater than equal to 2. Right. So what we are told is we have this words which is array of strings and an integer k. Right. This is an integer. And what we are told is first we are given definition of prefix connected. Prefix connected definition for any two strings or any pair of strings a and b is their prefix of length k is going to be same for both. That means that their, if let's say we have one string abcd and another string abxs xx and k is equal to 2, their prefix of length 2 should be equal. So the prefix of length 2 would is ab for the string a, and the prefix of length 2 for b is again ab. That means they are prefix connected, and we are given that a connected group is such that each pair of strings in which each pair of string is prefix connected. And then at last, after processing these connected groups for the words array, what we need to do is we need to find the total number of groups with size greater than 2. Okay, great. Great, right? This is the entire question. Let's understand with an example more. So the example is we are given this. Yeah. I hope this is visible. Yeah. So what we are given? What we are given is four different strings. And what we need to do is we need to basically make connected groups out of it. And then we need to find what is the total number of groups of size greater than equal to 2. Right. So we are given k equal to 2. That means that for any group, let's say this is group 1 and this is group 2. And we have, let's say, some strings here. We have string A here, string B here. And this is group 2, we have string C here, string D here. Then C and D, or let's say we even have E, then C and D, C or E, or even E or D, any pair of strings should be prefix connected. Connected. What is prefix connected? What is prefix connected? Prefix connected is, it means that the length of 2 here, right? It means that the prefix of length k should be equal in both the strings, in both the strings, right? Right. And similarly here, these two should be prefix connected, right? So what does this mean is that we need to first find, basically we need to find the number of groups here, and then we need to return the number of groups with size greater than equal to 2. Okay, great. So can this and this be in the same group? Let's actually check for this example. Can this and this be in same group? What's the prefix of length 2 here? This is AP, right? What's the prefix of length 2 here? This is also AP, right? Are they same? Yeah, great. So these two can be put up into a same group, right? So these two can be put up into, let's say we have this group, group number 1. Now, what about these two? Can these two be placed into same group? What's the prefix of length 2 here? It's BA, right? So it's B and it's A. Is it equal to the prefix of length 2 here? It's AP here and BA here. Are they both equal? No, they are not equal, right? They are not equal. So this would be in a separate group. Let the group this string is in, and similarly for these two strings, let's check. The size, the prefix of length 2 here is again BA. Are they both equal? Yeah, they both equal. So this can be in this can be in the same group. Right. Let me erase this. So this can be in the same group. Right. So what we need to do is basically, how many groups we have now? These two are in the group 2, these two are in the group 1. Is this, are all the strings here prefix connected? Yeah, because all the strings have the same prefix here. Are all the strings here prefix connected? Yeah, because all the strings have the same prefix here. That means that for each group, this is our first observation that we got from the example itself, right? That each group must have same prefix, must have same prefix of length k, right? Of length k. So this is the first observation what we got, right? So what would be the answer here, right? We got two groups, and is this group, the number of strings in this group greater than equal to 2? Yeah, right. The size of this group is greater than equal to 2. Similarly, for this one is also the size of the group is greater than equal to 2. So the answer is 2. We have two individual groups, and each group size is greater than 1. Right? This is what we are given in the question. First we are given that we are given an array of strings and an integer k. Then we need to find, we are given definition of prefix connected. The definition of prefix connected is that the prefix of length k is same for both the strings. And then we are given a connected group. A connected group is a group where each pair of strings are prefix connected. That means that each pair of strings have same prefix of length k, of length k, right? And then the total number of groups with size greater than equal to 2 is our answer. We need to return this is our question. We need to return total number of groups with size greater than equal to 2. Okay, great. So this is our example. So how are we going to solve this, right? We got our first observation that each group must have the same prefix. Okay, great. So what, let's do it brute force. Like, what's the brute force solution here? Whenever we encounter problem, we first solve it using a brute force approach, right? Because it's correct but needs to be optimized. So what's the first, we are going to see the constraints of the problem. So we are given that the length of words array is around 1 to 5000. Okay, great. And each word's length is around 100. Okay, great. And the factor k is greater than equal to 1 and less than equal to 100. Okay, that's great too. And then we are given that all string in words consist of lowercase English letters. Okay, yeah, that's also great. So basically what we are given is that let n be the size of, so what we are given is in the, okay, so this is the constraints, right? Let me also read the comments. So, and even then, fourth, I have heard it's done using something called heavy light decomposition and segmentary. I don't know any of them. I got the idea of fourth one. Basically, I figured out brute force. Okay, great. We are going to discuss it, so don't worry. Like, we can also do it without using the heavy light decomposition. We can do it using that too. So yeah, teen here. Yeah, sure. Like, if you are done three, you can watch the solution for the fourth one too. And even for these questions that you have already done, you can check if you find something new here. So yeah, this is actually also like, so this was actually a pretty good observation that we have to make, that each group must have same prefix of length k, right? And using this observation, what we could do is, how are we going to solve this proof force actually? Let's discuss it. So we could basically, for each string, right? Let's say we have this string a a x y and a x z, and then we have a o, right? What we are given is that, what we are given is that we need to basically divide it into groups, right? So what I would do is basically check how many, for this string, I would check if this or this, and then this and this and this and this would are prefix connected or not. And for example, this and this is prefix connected, right? So I'll mark this as visited, and also mark this as visited. So this would basically, for each non-visited array, I will iterate and find out the answer. How are we going to check if this and this is prefix connected or not? So this is the brute force solution. What we could do is, we could basically start from here. We could check if it's already marked visited or not, and then we could check basically we could check for each pair of non-visited strings in the words, if this is if this is prefix connected with something or not. And then what we could do is basically mark this string, including it with all the strings it is prefix connected, as one group, right? Right. Using brute force approach, let's say we don't worry about complexities, we don't worry about anything, then this approach is fine, right? And then we would basically go to the next string. We would check again to all non-visited arrays if we could find any prefix connected strings. If we found any prefix connected strings, we are going to mark this as visited as well, right? How are we going to check if any two strings are prefix connected? We are going to basically check their, if their prefixes are of length k are equal or not, right? If their prefixes of length k are equal or not. What would be its time complexity? Let's say the n is size of the words array. And m is size of each string, let's say. Each string. What would the time complexity here? This would be around, for each string, we are going to further check it with other strings, right? So this would be n into, for each string, we are going to check it for other strings, and to check if the prefixes are equal, we are going to need m, right? Iterations up to mth index. Because the maximum value of, whenever we calculate the time complexity, we take the worst case scenarios, right? The worst value of k would be m, right? The maximum value k could have. So this would be our time complexity, but this is too large. Too large, right? Whenever these problems occur, like, I hope you are already aware of time complexity. If you're not aware of time complexity, complexity is how to calculate it. You could actually ping it out in the comments. There are already resources available in the TLE channel for the same. So you can check it out there. But if you think you need something new, you can actually ping it out in the comments and there would be some new videos regarding it. Some updated or something. Right, just ping it out in the comment section. So yeah. So basically now we know that this is too large time. This is going to take too much time. So is there some easy way to basically group them? Is there some easy way to group them? So using this observation that each group must have the same prefix of length k, what we could do is, let's iterate once. Use the same, we will use the same array. Let's assume we have this array AXY, AXZ, and AAO. Right. Someone said they solved this in n star k. Yeah, yeah. That's actually a pretty good solution. That's actually also like what I'm going to discuss. Something related to it. So what you could do is basically, for each string, calculate its prefix string. What is the prefix string for it? Prefix of length k here. What is the prefix of length k here? The k is equal to 2 here, right? For this question, k is equal to 2. We assume, what is the prefix of length 2 here? It's AA. And let's say we store this somewhere, right? What is the prefix of length 2 here? It's AX. What is the prefix of length 2 here? It's again AX. What is the prefix of length 2 here? It's AA. Can we do this? Can we do this? Can we count the number of values where we get prefix as AA, as AX? Right? We can easily calculate it, right? We could keep a dictionary. Just 1 second. We could keep a dictionary here, or some map, if you are using C++, right? And basically count the number of places where we got AA as our prefix string, a number of places as we got AX as our prefix string, because this property, that in each group every string must have the same prefix, right? So using this property, what we are going to do is, we are going to calculate the prefix string for each, let's assume this string, for each word in the words array, and then we are going to basically count the number of places where we got this as our prefix string, number of places that we got AX as our prefix string. We could easily count this using dictionary or map. Did you got it? Did you got it? So using this, we could easily calculate it. String type would be a better solution, I guess. Someone in the comment typed it. Yeah, you could do that, but I think that would be an overkill because this worked, right? We are basically going to, yeah, right, exactly. Yeah, that would be an overkill. Someone also commented the same thing. But here you could just iterate each string, right? Keep store its prefix here, AA. And again, for this, you're going to store its prefix. We only have one string currently of prefix ax, and when you reach here you're going to basically increment this value. Now we have two strings with this prefix, and again here you're going to increment its value. Now you have two strings with this prefix, two strings with this prefix, right? And you know that if their prefix is same, right, we have two strings, each of these strings prefix is same, right? For each string there its prefix is going to be aa. That means that this, all the string with this prefix forms a group. This is group number 1, and all the string with this prefix forms a group. This is group number 2, right? Using this you can easily iterate each string and easily store the prefix values and find the answer, find your final answer. Yeah, yeah. Like there could be multiple solutions. You can do it with try. Someone commented, he got submitted. Yeah, you could go with try. I think I didn't thought there, so I'm not sure like how it's going to work. But yeah, there could be multiple solutions for this problem. But I think using this, we easily use map or dictionary and it pass. So you don't have to think like that much. So you could easily pass this solution. So let me also show you my code. So this, yeah, here we are. So yeah, see the code is very small here. So what we do, we are iterating each string in the words array, and what we are calculating, we are basically iterating from 0th index to the kth index, and we are pushing this into a new string, and we are basically incrementing the number of places where we got that string, right? Number of places where we got that prefix. And finally we are going to, here we are checking how many prefixes had the total number of string that had the same prefix greater than equal to 2, and we are incrementing our answer according to that, and then we are returning the answer. So this is pretty straightforward and small solution. Just one case here. What if in this same array there is one edge case here, you could say I got a wrong because of it. So yeah, let me also discuss it. What if we have one more string? Let's say we have two more strings who which are a and a, right? The Yeah, I hope my screen is visible. Yeah, yeah. So let's say we add two more strings with each of length 1 and their size is less than k. Right. If we don't block them, what's going to happen is basically this is also going to mark it in our dictionary, and first it will mark it as 1, the string a as 1, and then this 2 is going to increment it by 1, and this string would also pass into our final answer. But this is not the right answer, right? We need strictly the prefix of k, prefix of length k, not less than k, right? So we are basically, I have this if condition. If the size of the current string is less than k, we are basically going to ignore that particular string. Hope you guys got the answer. So here what we did, we basically iterated each string and then we basically marked the prefix, its prefix into into our dictionary, and then we checked how many strings had the prefix as aa or ax or whatever prefixes we have, and then we check if their size is greater than equal to 1, then that means that it forms a group, right? And then we calculate the total number of groups. So this was the entire solution. So this was the problem, and then this is how we solved bit by bit by bit. Hope you guys got the solution. Now let's jump to the third question, and then we'll go with the most hard, or like the best question out of the entire contest, which was the fourth question. So yeah, let's jump into the third question first. So yeah, the house robber. This is again a very standard question. So you are given a profession. First, let me also read the comments. So yeah, anyone who was able to solve the fourth one, we are going to discuss the fourth question too. Don't worry. So my code is 99% similar to yours, dude. That's actually worrying, right? We should worry about it. We shouldn't get flag for it. Anyways, yeah, this was like, yeah, great, great, great. What approach did you use? Because I was not even to find out the concept use. Yeah, we are going to discuss it. We are going to discuss the fourth question. And then someone typed, next question, please. Yeah, let's move on to the third question. If you guys have any doubt, you could actually ping it out in the comments. I'm actively watching it. So yeah, the house robber problem, the house robber 5, where you are given a professional robber planning. You are a professional robber. Okay, great. I am a professional robber. Planning to rob houses along a street. Each house has a certain amount of money stashed and is protected by a security system with color code. Great. You are given two integer arrays, nums and colors, both of length n, where nums I, or the ith index of the nums array, is the amount of money in the ith house. Okay. And colors I is the color code of that house. Okay, great. So basically, this is our third question. Someone typed that I tried third question but could not think of any way to solve it within n square. Okay, yeah, we are going to discuss it, don't worry. So the first thing we are given is that we are given two arrays. One is the nums, right? This question, yeah. And the another one is colors, right? This array tells us money in each house. This tells us the color code of the house. Of right. So this is what we are given. And we are given that we cannot rob two adjacent houses if they share the same color. Okay, great. Okay, great. So this is also what we are given. Yeah. The second point that we got from the problem is we can't rob what we can rob two adjacent houses of same color code. Same color code. So great. So then we need to find what is the maximum amount of money you can draw. Okay, great. First, this is the entire problem, right? So first, let's actually understand the problem. What we are given is, let's say we are given four houses, right? Let's say we are given four houses, one, two, three, four. Now each house has two things. Each house has some money in it. Money in it. Let's say this house has money four. It has four. The amount of money it has is four. This has three. This has two. This has one. Let's say these are number of coins. Or this is the amount of money that the house has, right? And this amount of money is given by an integer nums, and we are also given a color code for each house, and that color code is given by our color array or colors array, I think. Yeah, colors array. Let's say this has the color code as 1, this also has 1, this has 2, and this has 3. And what we are told is that we cannot rob two houses simultaneously or adjacent houses with same color code. That means we cannot rob these and this house and this house together, right? Because they share the same color code, so we cannot rob them, right? We could either rob one or we could either rob two. We cannot rob them both simultaneously. This is the entire question. And then we need to find out is that what is the maximum amount of money we could rob, right? So let's say what houses would you rob, right? Now let's start from the leftmost side, right? Let's start from the leftmost side. So first we could can we rob this? Like, let's actually see the overview for it. The most amount of money is this house has the most amount of money, so let's rob this. As we have already robbed this, can we rob this? No, we cannot rob this. Then we would move to the third house. Can we rob this? Yeah, this and this, the previous house, or the can, yeah, let's actually rob this. So because this has the maximum amount of money among all the houses that are left. Can we rob this? Yeah, we can rob this. So what is the total money we get? Total money we get would be 2 plus 1 plus 4, or 4 plus 2 plus 1. This would be 7, right? Okay. In the comment section, I'm getting a demand to explain the second question too. So sure, like after this question, I'll explain the second question once again. We'll go through the second question. Today I wasted 20 minutes with the wrong DP state, and that too by an inch. Thought I was able to solve it. Though I was able to solve it eventually. Okay, great, dude, great. Okay. After this question, we are going to again discuss the second question. Same here, but quite easy to think in form recursion perspective. Yeah. Okay. Let's actually continue with the same question. So what we are going to do is we have to basically decide what houses can be robbed, right? So can we go greedily here? We would rob the house with the maximum. Like let's think, right? Let's think in the brute force terms. What methods do we have? First, we could actually think greedily. We could rob the house with the largest amount that we have, and then we would move to the second largest one. We would see if we could rob this, because like in this case, what happened? Uh, the adjacent house was already robbed, so we couldn't rob this, and then we will move uh, with the other houses, right? But would this work every time, right? Would this work every time? Would greedy work every time? Let's actually see, right? See with some example. Let's say we have houses 1, 2, 3, and the amount we have is 10, 9, and 9, and the color code is 1, 1, and 1. So first we will rob this house, right? Because this has the highest amount. But let's say we rob this house. Can we rob this house? No, we cannot, because these two have the same color code. Actually, these three have the same color code. And we cannot basically rob two adjacent houses with the same color code, right? So what we need to do is basically we could not rob this house, right? And similarly for what is the next number with what is the next amount we could get? This house, can we rob this? Again, we cannot rob this, right? So what would be our answer? Our answer would be 10. But is this correct? No, not right. This is not correct. Why? What if we robbed this house and this house, right? If we robbed this house, our sum would be 9 plus 9. This would be 18, right? And this is much greater than 10, right? So we should actually, like, the proper answer is, if we rob this house and this house, although these the amount any of them is not the greatest, even though it's not the greatest, but if we go according to this sequence, it produces more result. We are able to rob more money, right? And what we need to do is, we need to basically, in this question, we need to find the maximum amount you could rob, max money you could rob. Right. Okay, so that means that the greedy wouldn't work. Okay. Whenever it comes to state where greedy doesn't work, you can think in terms of recursion or dynamic programming, or like, do we need to change some formula, right? Like, in greedy in this way wouldn't work, right? If we go from the highest to the lowest. Let's actually think, like, how are we going to solve the problem then? How are you going to solve the problem then? How can you solve the problem in the brute force way? Right. So there is one thing that you need to observe is that, when are we going to choose? Let's say we have we have four houses, and the amount we have, let's say we have some arbitrary amount. Let's say we have 4 year, 5 year, 3 year, 2 year, and the color code we have is this, right? Then, then there is one observation that we have to make here. When are we going to decide? Let's say we are iterating from last house, we are going in the sequence. When are we going to decide, are we going to take this house or not, right? This is pretty standard problem, actually a pretty standard DP problem, right? Standard takes, not takes DP, right? How are we going to decide, can we take this house or not? We can take this house if the previous one is not taken, or previous one is taken but of the different color, different color code, right? We have two options: either the previous house is not taken, or the previous house is taken but of different color code. What if this is of the same color? Then we cannot take this house, right? That means that, if that means that if the previous house is of the same color code, just like it is here, and it is taken. Then that means that we cannot take this house. Right. So this is our first observation. Right. So we are going to check what we could do or not, right? But let's say we are doing it brute force way. What does the brute force ways check? It says check always. Okay. Check. I hope I'm audible. Am I audible? Chat. I hope I'm audible. Yeah, I'm audible, I think. Okay, great. Yeah. The brute force way would be we would be checking all the ways, right? Right. So what we are going to do is basically we would check all ways here, right? All different ways where we could basically take the houses, right? One more observation that you need to do is, let's assume in this same house, let's say we are at this house, right? Let's say for some reason, let's actually take one more example here. We have again four houses, one, two, three, and four. The amount we have is again arbitrary, 4, 5, 7, and 3, and the color code is same, 1, 1, 1, and 1. How, what is going to happen if we take this house, right? If we take this house, that means that we cannot take this house, right? If we take this house, that means that we cannot take this house, right? So, so, let's say we are iterating from the least to the maximum, right? Those who have observed, those who are seeing, those who are already aware of dynamic programming, this is a pretty standard question here, right? Of the DP, where what we do is basically we start from the leftmost index and we keep on iterating, and we basically check all the possible ways that we could follow. And how are we going to check all the possible ways? While we are iterating, what we are going to do is we are going to store some state. Let's assume, let's make a different vector here and let's name this dp, right? Here I'm basically jumping towards the solution now. So what observation we had is basically we have two different options. Either we could take this, either we could rob this house, or either we couldn't. If we are going to rob this house, what are we going to do? We cannot rob the previous house, right? And if we are going to rob this house, there are two ways. Either the previous house, we have not robbed the previous house, or we have robbed the previous house but it's of the different color. So what I'm thinking is, let's say we are going to rob this, irrespective of anything, we are going to rob this, and we have already robbed this too. Right now, this creates a problem because both of them have the same color code, but we cannot rob two consecutive or two adjacent houses with the same color code. So what are we going to do is we are going to check the answer that we got here, right? And this dp, this is going to store max amount, max amount we robbed, we robbed for each index, for each index, right? This, here we are going to store the max amount we could draw for each index. And what we are going to do is as we cannot rob this, I would check what was the max amount we robbed till this index. And this would be our answer for this index if we took it. Am I right, chat? Did you got it? If you guys are not aware of dynamic programming, it's highly unlikely you would get the solution because it's pretty standard dynamic programming question. So I would highly recommend you to go through the TLE resources of dynamic programming. Right. So again, let's actually understand it more deeply. How are we going to solve the problem? And if you guys have any doubt, you could actually ping it out in the comments. So what I did was, I had this DP array. I kept this DP array. This was actually storing the maximum amount we robbed for each index. Right. So DP, now again, let me actually type it again. Let's say we have 1, 2, 3, 4. We have 4 houses. This nums would tell us the amount they have. Let's say they have arbitrary amount 3, 5, 3, 2, and 7. And this colors will tell us the color code. Let's say they all have the same color code. Now we make one more vector dp, and this stores maximum amount till ith index, right? dpi going to help is, what we did was, if we are going to take this, if we are going to rob this, what we did was, we are to rob this, we are going to get 7 points, right? We are going to add 7 to the maximum amount we robbed a house at index 1, because we are assuming that we didn't get this one, we didn't rob this one, right? So in this way we are able to check all the states, right? We are going to check all the ways we could get our answer, right, chat? So yeah, this is our dynamic programming array. What is the maximum sum? What is the maximum amount we could rob till the first index? It would be 5, right? We could rob this house and we would get 5 as our answer. And now what is the maximum amount we could rob here? Now this is the beautiful part. Right. This is the beautiful part here. Now we have two cases, right? We could either take this, or we could either not take this. If we take this, if we rob this house, right? If we rob this house, we are going to go, we must assume that we didn't took this house, right? If we took this house, what would be the money we would get? We would get total money as 3, right? Because we got this, but we cannot rob this house then, right? Right. If we took this, we cannot rob this house. That means total money we would get is 3. What if we didn't rob this house? What is the maximum money we could collect till the second index? If we didn't rob this house, that means that we could rob this house, and the maximum money we would get would 5. Right. So what would be the answer here? This would be 5 here. How are we going to calculate it in the DP way? Right. How are we going to calculate it with DP way? We are going to use this index for the same. Right, this index I'm going to show you how are we going to calculate it in the DP way. So let's say we took this or we didn't took this. If we didn't took this, that means that we wouldn't care if we took the previous or not. Right, so the answer here would be DPI minus 1. The answer would be the answer it had at the previous index because we didn't took this. Right. Right, chat. And if we took this, the answer would be the amount this index had. What amount this index had? It would this is nums I plus the amount we had when we were two houses back. TPI minus 2. Right. Why DPI minus 2? Because the maximum amount we had, we are not going to take this, right? Because if we are going to take this, we are not going to take this, right? So the amount we had here, right? And there is one more thing that we must uh, notice. Here, all colors are same. What if color is not same? These two exist when colors are same. Colors I minus 1 is equal to colors I. Right. This is going to happen. We would have these two states when the colors are same. What is going to happen if the colors are not same? Let's assume the color for this is 7. So how are we going to calculate here? We are either going to take this and either going to not take this. If you don't take this, the answer is again same. The maximum amount we had pre till the previous house or till the previous index. Otherwise, 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 if we take this, this would be nums I plus dpi minus 1. Right. Because the colors is not same. Not same with the previous one. These two are different. These two are not equal. Right. Right. In this way, what are we going to return? We are going to return dp n minus 1. This was give us the maximum amount we had till the last house. Right, chat? So this is like the pretty standard dynamic programming problem, right? Pretty standard dynamic programming take not take problem, where we kept a different state here, and here this DPI tells us that it stores the maximum amount till the ith index, right? And for each index we calculated either we are going to take it, either we are going to not take it, and it depends either the colors are same or not. If colors are not same, then if we take it, the answer for this index is the previous money we had, the maximum money we could have till the previous house, plus as we took it, the money we got here. Otherwise, if we are not going to take it, the maximum amount we get till here is the maximum amount we got till the previous house. And similarly, if the colors are same, the answer is if we took it, it is the maximum amount we had till two houses back, because last house we are not going to take, plus the amount we got by robbing the current house. And if we are not going to take, it would be the amount we got until the previous house. And we are basically we will take the maximum of both, and then we are going to fill it or store it in a TP vector, right? So what would be the answer for it? What would be the answer for it if we took it? The num size is equal to 2 here, right? 2 plus dpi minus 2 is 5. 5. So this would be 7. If we didn't took it, it would be 5. What is great? 7 or 5? 7, right? So we are going to fill this with 7. And here, nums I plus dpi minus 1 is 7 plus 7. So this is 14. Right? Or the if you are not going to take it, the money it had till the previous house, this is also 7, which is greater, 14. Right? Right, chat? So here, what is our answer? 14. So this is how we calculated it using dynamic programming. or using the previous state, right? So its time complexity would be O of n, and its space complexity would also be O of n. You could actually reduce the space complexity, right? Because if you notice, we only need the previous state and the state previous of that one, right? You could actually store it in some variable and then use it, right? But for explanatory purpose, and like it did worked in the contest, right? So I used it, right? In the I've used it pretty much using my first intuition, and this is how I did it. I hope you guys got it. If you have any question, you can ping it out in the comments. I'm actively watching it. Now let me also show you my code for it. So here's the code. Yeah. So again, first we are basically initializing the size, and here's our DP array. And the first state is always equal to the money we would get from the first house, right? And then we are basically calculating it. Again, if the colors are same or not same, we have two options. If colors are not same, it's always advisable to take this, right? Because money is always positive, right? We would always get positive. Here are the constraints of the problem, by the way. That the n is less than equal to 10 raised to power 5 and greater than equal to 1. And the colors are, again, it ranges from colors, and the amount we get, it ranges from 1 to 10 raised to power 5. So it's always positive, right? So here, if here a is basically storing for uh, each state, right? What is the maximum amount we could get, and then we are basically storing it here, right? So if the colors are different, right, then the maximum amount we could get is the amount that we could collect until the previous house plus the amount we got here, and then that is what we are storing, right? BB is equal to 0, it would remain 0. And if the colors are same, now we have two choices. Either we didn't take it, and that is we are storing in AA, the variable AA. And if we took it, what we are doing, we are basically, we would, the if we took it, the sum would be equal to the money we got from this house plus the money we got from the house, two houses backward, the house previous to the previous one, right? So this is how we calculated that. We stored the we stored for each state, and then we returned the dp dot back basically returns the last element of the dynamic programming vector or the dp vector. This is how we solved it using dynamic programming. Okay. If you guys have any doubt, or if you want to share your approach or like something, you could ping it out in the comments. Hope you got this solution. Let me actually read the comments. Thanks when it helped. This is worth subscribing. Thanks a lot, dude. Can you explain two P's? Yeah, let me actually go to the second question once more. Yeah, I use the same logic. Great, dude. Great, great, great. Let's actually go let's actually discuss once more the second question, and then we'll go towards the most awaited question, which is the fifth question, the palindromic path. Fourth question, sorry. Just let me give you the brief of. So in the second question, what was given was, the name of the question is number of prefix connected groups, and what we were given is we are given a array of string words and an integer k. And then we were given a definition of prefix connected. Prefix connected strings are strings with the same prefix until the length k, or the string which has the same prefix of length k. For example, if we have abcd and abxx and k equal to 2, as the prefix of length k or the prefix of length 2 is same for them, they are prefix connected. And then we are told to basically we are also given definition of connected groups. A connected group is a group where each pair of string has the each pair of string is prefix connected, right? Or have the same, have the prefix of length k is equal or same, right? And then we are told to find the total number of groups with size greater than equal to 2. So this was entire question. How we did it? The first thing what we did was we found out what we found out was, in each group every string would have the same prefix, right? Right, just actually this statement itself solves the problem. In each group every pair of string or every string would have the same prefix, right, of length k, right, obviously, of each, right? So what we are doing is we are basically for each string we are and we are calculating its prefix of length k. The prefix of length k for apple string is ap, k here is 2, right? And for this, what is the prefix string of length k for this is again ap, and for this it's going to be ba, and for this is going to be ba. And what we are doing is we are keeping a dictionary, and here we are calculating the number of strings with this prefix. The number of string with this prefix is equal to 2, and the number of string with this prefix is also equal to 2, right? So in this dictionary or this map, we are using this data structure to basically calculate the number of strings that had this prefix and number of strings that had this prefix, right? And then what this tells us is that this would form a group, right? All those strings with this prefix would form a group, right? Because here what we got as the major observation was that, and in any group all the strings would have the same prefix of length k, right? That means that if I calculate for each prefix how many strings have this prefix and how many strings have this prefix, and later this entire all the occurrences of this string, right, all the strings that had ap as their prefix would form a group, and again this would also form a group. And then I would check basically what after making this map or dictionary, I would check how if their length was is greater than 1 or not, because we need the groups of length greater than equal to 2, right? Yeah. So this was entire observation that I got from the problem. Right. The major observation was that each group would have all the strings. Each group, all the string would have the same prefix of length k. Right. So this is how I tracked all the prefixes and then I calculated the answer. Now let's move towards, this is how we calculated. We went to the brute force. You could actually rewatch the video. This is actually this video would be available on YouTube. So currently we are live streaming. You can also move backwards and see the solution for the second, like how we started with brute force and then we optimized it and then how we did it. And we also discussed our code. The code is here. Yeah, here. I hope this is clear. And now let's actually move towards the most awaited question. Again, someone commented, can anyone tell how one can solve all four questions on a contest? I think regular practice. Practice makes a man perfect. And for this contest, you would also need require some theory, because fourth question was little theory. So yeah, now let's discuss the most awaited question, the palindromic path queries. Yeah, where it is? Yeah, here. Let me read the comments once more. If you have any doubt, you could actually bring it out in the comments. Yeah. Now let's discuss the fourth question. Yeah. Let's go for the final one. Question number fourth. Yeah. So palindromic path queries in a tree. You are given undirected tree with n nodes labeled from 0 to n minus 1. This is represented by a 2D array edges of length n minus 1, where edges I equal to ui vi indicates an undirected edge between ui and vi exist. Right. So what we are given is we have an undirected tree. Undirected tree with n nodes 0 to n minus 1. And then we also have this 2D vector or 2D array edges where each edge is given by a comma b. This means that an edge from a to b exists, an undirected edge exists. And then we are given a string of length n consisting of lowercase English letter, where si represents the character assigned to node I. Got it? We are also given a string s, right, where si indicates a character assigned to node I. Okay, great. You are also given a string queries where each query I is either update UIC, change the character at node UI to C, formally update SUI to C, right? Either we have another type of query which is query UI VI, determine whether the string formed by the characters on unique path from UI to VI inclusive can be rearranged into a palindrome. Okay, great. Right. Queries, we have two different type of queries. One is update, where what we do is basically we update, we are given one index u and we update the string at the uth index to c. We are also given this character c. Got it, right? And then we are also given one query where we are given ui and vi. And here, this is actually very interesting. We have to calculate if all the characters from the path, all characters from UI to VI can be rearranged to palindrome. Right, right. And then what we need to do is, while we do this query, right, return a, what we need to do is we need to return a Boolean array, right, answer, where answer j is true if the jth query of type query UIVI can be rearranged to a palindrome, false otherwise. So this query would give us true or false, and this needs to be stored into a array, a Boolean array, and this is what we need to find or return. Got it? So let's go step by step. Sorry. So first we are given an undirected tree of n nodes, right? And then we are also like for this tree we are given edges, like which is a 2D vector where each index we would have this, uh, we would have a vector a b where this would tell us that an edge between a and b exists. And then we also have a string where si tells us the character corresponding to the ith node. And then we are given queries of two types. One update query where we have to update the youth character of the string that we had, the string s to the character c, which would be also given. And the another type of query we has is that we would be given two nodes ui and vi, and then we need to find all characters, all characters from ui to vi can be rearranged to a palindrome, right? All characters from ui to vi can be rearranged to the palindrome, or all characters in simple path or in path from ui to vi can be rearranged to a palindrome. Some aware of standard algorithms of graph and trees, this question would be something creative that you need to think of. So yeah, let's study about this question. Yeah, yeah. Yeah. So in this we are given edges 0, 1 and 1, 2. So this would make a tree. How would our tree look like, right? This would look like, so this would look like we have this edge from 0 to 1, and then we have edge from 1 to 2. So this is our tree, right? We are given an undirected tree here, right? So let me also write this undirected tree. Already written. Okay, great. And then we have a string is equal to AAC, and our ith character of string tells us about the ith node, right? This means that this is our zeroth character, zeroth index, and then first and second index. So this a corresponds to this node. So this node would have a as its value, and this node would have a as its value, and this node would have c as its value. Okay, great. And then we are given queries. What is our first query? First query is, there are two types of query. One is update query and one is query. First, here we are given query. Okay, great. So what we are given is query 0 comma 2. And what we need to do when we are given this type of queries, right? We need to check if all characters in the path from UI to VI can be rearranged to a palindrome. What are the characters in the path from UI to VI? So this is our starting point. So this is our ending point. And this is our path, right? This entire is our path. And we had to tell if all the characters in the path, what are the characters in the path? A, and C, can they be rearranged to a palindrome or not? Can they be rearranged? Is this a palindrome? No, this is not a palindrome. Can they be rearranged to a palindrome? Yeah, I think, right, if we put a C and A, they can easily be rearranged to a palindrome. Right, that's great, right? I think someone has commented a case to explain, right? I'll explain it to you once we are done with the fourth question. Okay. So yeah. So can this be rearranged to a palindrome? That we need to find it out, right? So how are we going to do this, right? How are we going to do this? Let's continue. As we are able to rearrange it to a palindrome, we are going to, this operation is a true operation, right? And this true, we are going to push it into our answer vector. This is what we are told, right? We are doing what we are told, right? And we post a true here, right? And now what's the second query? Update. This is of the query update. And what is it? We have to update 1b. So what this update query tells us, let's again go to the question, that this update query would give us an index u and a character v, and then we have to basically update the uth index of the string s to the character that it has given. Okay, great, great, great. So the index we are given is this one. This is our youth index, and this is our character C. Right. So basically, what we need to do is we need to update S1 to B. Right. So this A would equal to this would be actually change, and this R string would be updated to A, B, and C. 0, 1, 2. Also, our tree would also update. Our new tree would be 0, 1, 2. But here instead of A, we would write B, and here we would write what was originally C. Right. So this got updated. Right. The value of this node got updated. Great. Now we'll move forward. In update, we don't need to return anything to the answer. Now we'll move towards a third operation, which is query 02, which is again the same one. Query 0, comma 2. Right. That means that can all the characters from the part which starts from 0 and end with 2, can what are all the characters A, B, C? Can they be rearranged to a palindrome? Can these be rearranged to a palindrome? No, I think we cannot rearrange this to a palindrome. Right. Okay. Got it. Got it. So we are going to return for this query, we are going to return false, and we are going to push it to our answer. We are going to push it to our answer. So our answer vector would be, it had true previously and it had false due to the third query actually. So this we are going to return. So our answer is a vector with true and false. Is this our answer? True and false. Yeah, great, great. Okay. So this is our answer. So in this example, did you got anything like, right? There are two parts. One is this query part and one is this update part. Right. Let's simplify. Like how are we going to basically, let's start with this query part. How are we going to get all characters uh like what is the brute force approach, right? The brute force approach would be something like we would like every time we reach to a query path, we would start from this index and maybe do some DFS or some BFS and then find this path and then calculate all the characters, right? And similarly with update too, right? Let's also see the input constraints. Let me also see the comments. Let me see the let us see the input constraint. The input constraints are the length of this string. Length of this string is maximum 5 into 10 raised to the power 4. And okay, great. So the value of n is the number of nodes we have. This is less than equal to 2 into 10 raised to power 5. Right. And how many queries would we have? Again, same. This is 10 raised to power 4, by the way. Okay. And the queries, total number of queries would be again from 1 to 2 into 10 raised to power 4. Right. Okay, great. So let's actually, how are we going to solve this in brute force, right? Let's actually discuss that first. Let me read some comments too. Okay, let's continue. How are we going to solve this in brute force? For brute force, let's say we had a query. What we would do is, just how we discussed, we would start from this index, the starting index, and make a TFS call and collect all the characters, right? And then we would check if we could make this a palindrome or not. How are we going to, let's actually, this is our query number one, right? Let's actually discuss. We have two queries, right? We are already given the string and all, right? We just have to process two queries, right? So queries. Let's discuss query by query. First, let's discuss the query one. Query AB, right? This query AB, let's say we have this tree and we have these characters, right? And we have this query from let's say 1 to 4. So this is our path. We could make a BFS call starting from this, DFS call starting from this, and calculate this path and get all the characters from this path, and all the characters would be B, C, and D, and then rearrange it. Try all possibilities to rearrange this to a palindrome, right? This DFS call would took something like uh, O of n complexity in simple terms, or this would takes this much time, right? And for checking palindrome, I'm not sure how much time we are going to take, right? So let's simplify it, right? Let's start from checking palindrome. When is a string palindrome? When is a string palindrome? Let's say this. Can this be rearranged to palindrome? No. Right. Can this be rearranged to a palindrome? Yes, we can. Right. A palindrome is a sequence where all these two characters, right, and these two characters are same. Right. If we read it from first to last or last to first, this would still be same, right? This is the property of palindrome. There is one more property of palindrome that is going to help us a lot, right? When we are rearranging it, we could there is one thing we should notice here. We should notice in this palindrome, each character would have its mirror character, right? Am I right? Right, each character, if this string is palindrome, each character here would have a mirror character, right? This is our first observation. Each character has its mirror, has its copy in mirror, right? Let's say this is the mirror. That means that these two characters should be same and these two are same, right? This is the property of palindrome, right? That each character will must be same, right? If you are taking this point as its mirror, right? That means that this sentence means that there the number of occurrences of each character must be even. Am I right? Number of occurrences of each character is even, right? Right, right. So number of occurrences of each character is, yeah, even, right? But what if we have string like A, B, C and A, B, right? Can this be rearranged to a palindrome? Yeah, let's keep C as the middle character, then we could have place B here and A here, and we make this mirror across this character, then these two are same and these two are same. This is also a palindrome. If we read it from here, if we read it from backwards, this is that would result in the same string, right? So we could have one odd character, right? One odd character. So this is our second observation. First observation is that each character would have its mirror, its copy in the mirror. That means that number of occurrences for each character is even. But there's this exception when the string length is odd. We could have one odd character, right? Using these two observations, we we could come to a conclusion that if we could have only one character with odd occurrence, right? Right. So basically, if we got all the characters, right, we could check palindrome by checking frequency of each character A to Z, right? And we should just make sure that only one or less than one, only one, only one or less than one odd frequencies exist, right? This step would take, we could iterate from A to Z. This would take 26 operations, right? We need to check from A to Z, right? So this we are going to check in 26 operations. But how are we going to check how many characters we have, right? How are we going to check how many characters we have? We have to basically iterate it. This is taking too much time, right? The queries are, again, we have n queries, right? The maximum amount of queries we could have is n, and n is less than equal to 10 raised to power 4, 2 into 10 raised to power, something like that, right? You got the gist basically. If you're doing this question, fourth question, you are already like you already know about the time complexities. So this is still little costly, right? That we are doing n operation this and 26, then each query is basically taking n into 26. So this would be finally n square into 26, which is a lot, right? This is a lot of time we are still taking. So how are we going to basically break it even more? So there is one thing that we could do is, right, we only want one uh, character or less than one character, or rest we want as even, right? Let's say, what if we used bit masking here? We are optimizing step by step, right? What if we did bit masking here? We masked A as uh, set bit of first bit, that is 1 0 0 0 0, and we masked B as set bit of second bit, 0 0 0 0 dot, right? And similarly we go down, we we go on till the character Z, and the Z is set bit at 26th bit. Z is set at 26th bit, right? So this would be 0 0 0, and we would have 25 zeros. Okay, right. What if you use bit masking? Yeah, how is bit masking useful? How is bit masking useful? So using bit masking, what we could do is basically for each character, let's say we had B, C, D. What if we place this B with its bit mask? Its bit mask is 1 0, and C with its bit mask is 1 0 0, and D with its bit mask is 1 0 0 0, and we did XOR of entire path, right? If we did XOR of entire path, right? First, why are we using bit mask, right? There is this problem that either we need frequency for we need to calculate frequency for each character in entire path. And how are we going to get entire path? We would basically do some DFS or BFS call. Then that is very costly for each query. So how about using some HLD? Yeah, we can use heavy layer decomposition. But yeah, let's do step by step. First, we are going to understand how are we going to make this query efficiently, and then we are going to deal with the update queries, and then we are going to finally make our answer. Okay, so basically, using this bit mask, what we did is we replaced all the characters by its bit mask, and then we could use the XOR property. What does the XOR property says? XOR property says that if we are doing XOR of the same set bit, if we are doing XOR of 1 and 1, this is the sign of XOR. If we are doing XOR of same set bit, this would result in 0, right? This means that if we did XOR of all the set bits, we would have only one in the resultant XOR. We would have only one singular set bit in the resultant XOR if the string that we are going to get is palindrome. Can we say this? Right. Because if the string is palindrome, it could have only less than one odd uh, odd frequency for each character, right? As we are yeah, there are actually concepts of a variety of concepts actually, right? bit masking is just one of them, right? So what I thought was basically what I thought was how are we going to reduce this? First I thought was can I if I bit mask each character, right, and calculate XOR of this, right? As the XOR is going to be right, but let's say we had this sequence A and B. So this the equivalent to this would be 1, this equivalent, the bit mass equivalent to this is 1, the bit mass equivalent to this is okay. I think my voice would be clear now. Is my voice clear? Right. But let's say we had this sequence. Hello, I assume my voice is clear. Hello, I assume my voice is
सही है.
it's breaking in between. Let me actually check my connection. Let me actually switch to a different hotspot. Just 1 second. And now it break. Yeah. Hope my voice is clear now. I solved 58 minutes, so three problems. Let's actually discuss this problem, then we'll go to the chat once again. Right. So what we could do is basically we could bit mask each character to the for each character to the ith bit. We could set the ith bit for each character. And how this would help is we would use the property of XOR. If we XOR two same numbers, this would result in 0. That means that for any path we have, let's say we have this path. For any path, let's say we have this path. We would not require to calculate for each character what's the frequency. Right. Instead, we could just check the XOR for their equivalent. Because what's the bit mask equivalent of A? It's 1. What's the bit mask equivalent of P? It's 1 0. What's the bit mask equivalent of A? It's 1 1 1. As the property of XOR says that if at the ith bit, right, if at the first bit we have two same numbers, and if we XOR it, this would result in 0 or 0 at the ith bit. And similarly, what if we XOR this and this? This would result in 0. And we XOR this with 1, this would result in 1. We XOR this with 1, this would result in 0 again. That means that we had total even occurrences of the ith bit. But as you know, if we XOR this 0 with 1 0, our XOR would be 1 0. That means that at second bit we have odd occurrences, but at first bit we have even occurrences. Right. So this is what we used here. Right. We basically converted them to their bit mask equivalent and we calculated the XOR. Right. We calculated the XOR. And why XOR? Why XOR? Why are we using the property of XOR here? Right? What's its need? We could, if we got all the characters, we could basically check their frequency right away, right? But that, I think it's always going to be a lot of time taking, right? Because we would require each character again, right? And we don't know the size of the path every time, but we could easily calculate the XOR. We could basically let's assume this is our root. We could easily calculate XOR from root to the ith index, and we could easily, using this property, we could easily calculate the XOR of any path, right? I hope you're already aware of it. Let me also explain it once again. Here, let's assume we have this array, and let's assume we have this uh, number 2 is it then this is the tree, and value is given in the value is circled basically, and these are the respective values for each node. What we could do is for any path, for any path for any path, it's very easy to calculate XOR for the path. XOR for path is easy and efficient to calculate. How we could easily calculate the XOR from root? This is our root index, right? We could calculate XOR from root to ith index. Root to ith index, and then let's say we need to find the XOR of this path, and we have XOR from root to ith index for each uh, let's say for each node, right? And this is basically stored in a array xr, right, where xr gives us xrj basically gives us XOR from root to jth index. Right. So using this property, we could easily calculate. First, we would pre-calculate XOR for each path, right? And then what we could do is basically for any path, let's say we need to calculate XOR from for this part, and this is our root. What we could do is we could easily, for XOR of path is equal to XOR of 2 by XOR of parent of 1. Right. Am I right here? Am I right here? This question actually requires a lot of concepts to be already known. You implementing it would require you a lot of concepts, but I think logic is fine here. This is logic what we are using to calculate if to find if the path could make palindrome or not, right? By placing each character to the its bit equivalent, the bit mask we have applied here, and using that bit mask, we could use the XOR property to find if all the elements in the path, if the XOR of all the elements in the path is 0 or only one set bit is in the XOR path or not, right? And the XOR path can easily be calculated. We could calculate XOR to 2. This would give us XOR from this entire path, XOR of this entire path, and this would give us the XOR of its parent. So XOR of this by this would give us XOR of this path, right? Right, chat. Let me also see the comments if you guys have any doubt. Today's 3 of 4 was done. Is there something I should particularly focus on? I think you should just focus on getting doing faster. This actually requires a lot of concepts. I don't think one, like if you are already good with trees and graphs, then you can actually study those concepts. But I hope you got that right. Using XOR from root to any path, we could easily calculate the XOR of any path, right? Let me actually take 2 minutes of water break. Let me drink water. Yeah, chat, I'm back with my water break. So, have you been interviews to FANG or MANG companies? They asked, do you have higher difficulty of O and DSC interviews compared to lead code contest? I don't. Yeah, it's comparable to lead code contest, not like specifically lead code type. But yeah, I hope so. I'm not off to too many interviews to be really honest. I think, but yeah. So yeah, using this is a second observation that we could use. So using this, we actually transform the problem to basically calculating XOR of the path, right? To basically calculating XOR of the path. And even using, if you use this concept, even the update query, what we are doing, what the update query does, it updates the ith node, the character, it updates the character of ith node, right? So instead of updating the character of ith node, we would be updating the number of ith node or the value of ith node or the bit mask of that corresponds to the character, right? Bit mask of the character of the character. So using this observation of Zor and basically replacing these characters with their bit mask, we manipulated the problem to a numbers problem, right? What we are given now, using this method, what we have done is we now have a tree. Let's assume this is our tree, 3 4, and each node would have some value. This would have, let's assume this has 1, this has 2, this has 4, this has 8, this has 2, right? And now what we have two type of queries. One is query type of query, where we need XOR of a path. XOR of a path, which can easily be calculated, right? We just calculated this formula, that XOR of a path is XOR till uh, one of the indexed, and then XOR of the parent of another one. XOR of the index which is at the farthest, XOR of, let me write it here, XOR till farthest, right? This correspond to this, and this into XOR of parent of closest one. There's one more case here. Let's assume we have this tree like this, 0 1 2 3 and 4, and we need to calculate XOR for 3 to 4. How are you going to calculate it? How are you going to calculate the XOR of this path now? Right. So the XOR of this path is, again, like if you think, we have XR. XR is XOR from root to ith index. Right. Ith index. Right. We have this XR array which gives us XOR from root to ith index. And what we are going to do is, basically we could calculate for this path. What we could do is, we could actually use a general formula here which is much better, which is basically XR of 3, XR of 4. XR of 3 would give us XOR of this path, XR of 4. Right, someone actually commented we could use LCA. Yeah, exactly. We could, exactly right. You are completely right. Right. XR of 4 into XR of LCA of 3 comma 4. What's LCA? I'm hoping you're already aware of it. It's least common ancestor. Right. So least common ancestor. Yeah, someone commented binary lifting. Yeah, absolutely right. We could use binary lifting to calculate the LCA. So for any path A to B, right? For any path A to B, the XOR would be XOR of A into XOR of B by XOR of LCA of A comma B. Versus, what is LCA? We will use this formula a lot, actually. We'll use it later. How to use segment tree in this. Yeah, I'll actually explain it. I was not able to handle update queries. Okay, let me tell it how are we going to handle it. So yeah, this for calculating XOR from a path from A to B, we could use this formula. Right. What is LCA? LCA is least common ancestor, which is this one. Right. this this here is LCA, right? So what would happen? XOR of A would give us XOR from root to A for this. Let's say A is 3 and B is 4, right? XOR till 4 would give us XOR from 0 to 4. And if we calculate XOR till LCA would give us XOR from 0 to 1. Now, did you understand, like using this uh, visual, like using this visual diagram, we could understand that if we have we did XOR twice, it would always give us 0. XOR of any number twice would always give us 0, right? We did twice here, right? We used this path, right? We used 0 twice. The value 0 would have, we used it twice. So this would always result in 0. This we are using it thrice. When we have when we are XORing it 3 times, this would give us this value. So this would be once used. Again, this would also be once used. The value here is also once used. This value would be also used once. This value would be also used once. So this would give us the XOR for entire path A to B, right? No, 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 no. Right. Now what we did was we have completely changed the problem. We have changed the problem. Now we have a tree, and for each query, we just have to uh, take XOR of the path from A to B, right? And for update, we have to update the values. Now, how we could use it? How we could use it? What I did was I used segment trees, lazy segment trees. This is the solution, right? We converted the problem into a XOR problem using bit masking. And how to implement it? We could use segment trees using Euler-Tor algorithm plus binary lifting to calculate the LCA. For LCA, right? So these three algorithms we used here. I hope you guys are already aware of lazy segment tree, how lazy segment tree works, right? If you because this again is an topic of its own. Euroto also, you could actually check it out, some blogs of TLE Eliminators for the same, and then binary uplifting, because these actually are very heavy topics, to be honest, right? So what I did was using Euler-to, like, let me give you just a brief of it. uh, like in lazy segment tree, we lazily update the values. For example, let's say we have 1 2 3 4 and 5. This is our vector and these are the values, right? When we need to update the value, when we need to, let's say we have this number 2 and we need to XOR 2 from this to this, all indexes, right? How much would this query take? This would always take the size, right? Let's say the size is SZ. This would take this many operations to do this, right? But instead, what we do is in segment tree, the segment tree help us to update a particular value. In lazy segment tree, we could update a range of values in one go, right? That's like a simple thing. This like a simple summary of lazy segment tree. Right. Euler-Tor is an algorithm which is basically in a tree, algorithms like segment tree, Fenwick tree, we could apply it easily to our arrays or flattened, or any, we could easily apply it to arrays or vectors, right? But for a tree, it's very hard to apply. So in- for a tree, we have some algorithm that basically flattens the tree, and using that flattened tree we could easily apply segment tree or lazy segment tree on there. and using the on that flattened tree we turn tree to flattened array, and in this array we apply our lazy segment tree. Got it, chat? How to implement? Okay, we have a lot of doubts. Let me actually take it one by one. Yeah, but the XOR expression will count the vertices above LCA till the root. Should that be wrong? Where would count? No, no, like I hope this part is. Let me actually explain the entire problem and then me how to give flatten. Give example. Yeah, sure. Sure, I'll give the example. But let me just explain the problem and then I'll go to doubts one by one. Right? Yeah. Let's go step by step. So yeah. So basically, we have this algorithm Eulerto, which basically flattens the tree, and then yeah, the spelling is wrong, right? Let me actually. This is E. Yeah. Yeah. So this tree gets flattened. Then we could apply lazy segment tree here using the XOR property to implement this. Right. For each query, we would calculate the XOR of the path, and each update we would basically do lazy updates uh, to the path. Right. And how does this entire thing work? Let me tell you using example of a tree. Let's say we have this tree. Let's say we have this tree. 0, 2, this is 1, and this is 3, and this is 4. So what edges we have 0, 1, 0, 2, 1, 3, and 1, 4. So let's say we make a DFS call. We started at root, right? And what we would do is basically for each root for each index, we would basically print the way how we did the DFS. Got it? Print the way how it did DFS. How did DFS go? It basically goes to the leftmost. It first it entered here. So we will mention this. Then it goes to the left index 1. So we print this, and then it goes again to the left index 3. Then it goes back, and then it goes to the right index 4. We print this, and then it goes to. It didn't come back, right? It goes to each. It goes here. So we print this, then it goes here, it print this, then this goes here, this is completely calculated, it goes to the 2, and we use this, and then we applied segment tree here. How can we apply segment tree here? Let's say we need to basically XOR 1 to all values of to XOR 1 to all values of 1, 3, and 4. What we could do is we keep a in time and out time for each vector. This in time and out time tells us how many nodes a particular subtree has. Let's say we need to XOR 1 to 1, 3, and 4, basically to subtree of root 1. So what we could do is in this array, we know that the subtree of 1 would start from 1, and few elements after it would be in its subtree, right? So what we could do is we would have this in and out time for each node. In and out time would tell us how many nodes after it would be in its subtree, right? So the best thing I would say is watch some tutorial regarding to all three concepts. That would help a lot, right? Because these three are qu- pretty heavy concepts. But yeah, this is how it we would have in and out time. This in and out time, if you are using black box, this would tell us how many elements on right, many elements on right side, on right of it, are in its subtree, right? So we would, if you need to XOR it, we could XOR this entire subarray, right? And like if you need to XOR entire subarray, we cannot use segment tree, right? Segment trees would take log n for updating each index, right? That's pretty costly. So what we could do is basically use a lazy segment tree. What does lazy segment tree does is this segment tree would be something like this, right? So what this does is it doesn't update each node, rather it updates its parent, and it doesn't even update its parent. It keeps, we have this lazy vector where we store that we need to update it, but we would update it when we require to use this particular node, or this particular in node, or this particular index, or right. Then we use lazy segment tree, right? So basically lazy segment tree is used when we need to update a range, right? But if we are using it using Eulator into a tree, we could update a subtree. We could easily update a subtree, right? So this is how we are going to implement it. Let me actually also show you my code, and then we'll go through each and every doubt, because I know there would be a lot of doubts. But yeah, my advice would be to first understand these three algorithms. You could also use, I think, like many people mentioned, you could use heavy light decomposition too. But yeah, this was the simplest answer that I could that I came up with during the contest. To calculate least common ancestor, we are using binary lifting. Again, this is a concept of its own. So yeah, let me also go through my let me also show you my code, and then understand the problem. So hope you got the main gist. The main gist was to convert each character to a bit bit masking set bit, where each character would represent a set bit. For example, A would represent a set bit at the very first index, and B would represent the set bit at the second most index, or the index just left to the least significant bit. And similarly, we would, for each character in the alphabet, we would have a bit mask, and then using this bit mask and using property of XOR, we would we basically transform the problem to basically, for the query became querying a path, a XOR path, and update becomes just updating it manually, right? To update it efficiently, we used a lazy segment tree, and to calculate XOR path, we used again lazy segment tree for the same. Using Gunato, we flatten the tree. And how are we going to update it, right? So update is again, once we flatten the tree, right? Let's say we updated XOR at 1, right? Let's say we got an update query. This is our flattened tree, right? 0 1 3 4 2. Let's say we updated, we got 2u. That means that we need to update second index with some different character, right? We would first convert this character to a set bit. Let's say this is something like this, right? That means that second, or like the position 2, we would require to update it to this some number. Let's say this position is not 2. Let's use a harder position. Let this position is 1. Right. Now we know that in XR, in XR array, we are storing XOR from 0th index to the ith index for XRI. Right. So we are basically this XRI is basically values for each of the flattened uh, are values corresponding to the flattened tree, flattened array we got by flattening the tree, right? And what we are doing is when we update one, we are updating 1, 3, and 4, right? Because if we change this value, the XOR that came from 0 to ith index, the XOR that came from 0 to third index, the 0 to the node number 3, the XOR that came from path from 0 to the node 4, all these path would change, right? If we change this number, right? So what we did was the change that is going to occur, we basically changed it for 1, 3, and 4 using this flattened tree, using lazy segment tree here, right? So yeah, this was pretty standard problem. We used these three concepts, and now let's actually go through code, because here code was actually very bulky. So let's understand step by step each function, what we used, how we used. So this DFS, what we are using, this again I said the in time and out time. If you are already aware, this is the Euro-Toll algorithm, right? This is used to basically flatten the tree. And this what we are doing, this is how we are, this is the binary lifting. This is used to calculate LCA fastly or LCA effectively. And how does binary lifting work? Let me give you a brief overview. Again, I would recommend you to basically learn about these on your own. Let's say this is the array. So what this is going to store, this up is going to store, up UI is going to store the 2 to the power ith parent of u. Got it. So for, let's say, u is equal to 0. So up 0 comma, let's say I is equal to also 0, is going to store the 2 to the power 0th parent, right? Which is the first parent. First parent of 0 is 4, right? And up 0, 1, just 1 second, is going to store the 2 to the power 1th parent, which is the second parent, which is first second is equal to 5. And similarly, up 0 comma 2 is going to store 2 to the power second parent, which is fourth parent. Here we don't have fourth parent, so this would be -1 or whatever you want to upload. This is binary lifting. This is used to calculate LCA. And this is the brief overview of it, right? So this is what I have done here, this line, right? So this DFS call, we are doing three things. First, we are calculating the value of up for each. We are basically calculating parent of in the powers of 2 for each index, and then we are calculating the in time and out time for each node, and then we are basically also flat. This is just a process of flattering the tree. Now this in sister, this is the just a helper function, and using this helper function, where are we using this helper function? In LCA, using LCA. And how are we calculating LCA? What we are doing is, first we are checking if u is ancestor of v. If u is ancestor of v, then LCA is u, right? Let's assume 1, 2, and 3. If u is ancestor of 3, right? That means that US are LCA, the least common ancestor. Right. And then let me check if my stream is working just once. Yeah. So this is how we are calculating. First, we are checking if U is ancestor of V is ancestor of any. If the first one is ancestor of the second one, then this is our LCA, right? And then we are checking for each of its parent, right? Now let's also move forward. Someone actually commented, could you tell us the how are we going to calculate the flattened tree? Yeah, let me actually explain you flattened tree once more. Let's say we have for this the flattened tree. This is actually an example for a tree which looks like 0, 1, 3, 4, and 2, right? Just- Yeah, yeah. So the Euler tool for this would look like 0. First we are here, and then we go to the node 1. So 1, and then 3. Oh, just 1 second. Am I audible, guys? Hello. Also, I don't think we are expecting to learn all these assessment I've been doing. Nobody asks more than standard TP. Yeah, this would work actually. Yeah, this is actually the flattened tree. Yeah. Uh, I think it's important to learn for getting good rank because these things do come in. Yeah, these standard problems actually need code actually bombard you with this stuff. Code forces, I don't think bombard you with this stuff till a very good rating. Yeah, this would be 0, 1, 3, 4, 2, I think. Yeah. And we also have an and out for each. So yeah, then what we do is we basically for each ancestor, you know what this means. This means that the 2 to the power ith ancestor, 2 to the power ith parent of youth node. We check for those if this is the ancestor of v. If this is the ancestor for v, basically update the youth value. So this is a again classic way to get the least common ancestor, and this is where we are calculating the ancestor. How are we calculating the ancestor? When we were doing DFS, what we did was we had an in time and an out time. You again coming here, when we entered here, our in time was 0. At this index, at each index, we would have this in time and an out time, right? This is calculated using Tn and Tout. Right. So in time here is 0. And when do we leave this? We leave this after iterating. We went here, and then we went here, and then we went here, and then we again came back. So we iterated, we took 1, 2, 3, 4, and then we again came back, right? So right. So each this would have some out time. So out time would be at 0 we are 1, 2, 3, and 4, and then we came back. So yeah, 4, right? We entered at 4, and then this we came back. This would be 5. Right. So basically, each index would have some in time and an out time. And to calculate ancestor is to calculate if u is the this is ancestor checks if u is the ancestor of v. So what we are checking is that if the in time of v is greater than equal to in time of u, and out time of u is less than is greater than equal to out time of v. What does this mean? This means that, let's say the end time was, okay, yeah, let me actually, yeah, someone in the commented tag does, is it necessary to learn these advanced topics? Yeah, for lead code, I don't think it's necessary to learn these advanced topics, right? But it's good to have, right? For lead code asks it's a lot. Yeah. So again, let's move on. So yeah, each would have an in time to out time, and this also tells us that, let's say if it starts for 0 and if it ends at 5, right? This tells us that if what would be the end time of it? It would start at 1, and where would it end? It started 1, it went here and went here, and 2 and 3. Let's say 3 at end. It and this ended at 4. Let's say this. And just one second, let me plug in my laptop, as it's been 2 hours, right, for our stream. Let me just plug in my laptop. Yeah, I'm back. Actually, I was actually having some problems. Yeah. So why this in time and out time is important is, this in time and output tells us how many nodes after this in the flattened array are uh, in the subtree of this array. Got it? Got it. And then this is actually very, like, if you, then this is actually pretty easy going, right? For each index, let's say we are here, we have this in time and out time. We could easily calculate two things. First, we could calculate what elements after on the right side comes in at subtree using the in time and out time. How many more elements did it traveled after it? It traveled 3 minus 1. How many elements? Two more. That means that these two are also part of this subtree, right? Similarly, we would have in time and out time for each array that we are storing in t in and t out. And this val is actually what we are storing in the val. We are storing the value of every node, right? What is the value of every node? That corresponds to the character that is at that character that is at the current node. For A, it is 00001. For B, it is set bit at the second index or set bit at the index just left to the least significant bit. Right? Right, guys? And then, so using this, we would have in and out time for each uh, index. And then we'll move forward. So yeah, this DFS basically it flattens the tree. It also helps us calculating the it is also help us implementing the binary lifting that would be used in calculating LCA. And ancestor, this is actually a using we are basically calculating if it's ancestor or not using the in and out time. We basically check one thing. If the in time of one, right? If in and out time of three comes under in and out time of 1, that means that 3 is a children of 1 and 1 is ancestor, right? What is the in and out time of 3? The in and out time of 3 would be like 3 comma 2 comma 2, right? Because it was here, it does not have any children, so it out time would be same. So and the in and out time for this is 1 comma 3. Now we calculate if this in and out time can is in under this. That means that the in time of this is less than the in time of this, and out time of this is greater than equal to out time of this. And if this is basically could come inside this segment, if we are taking 1 3 is segment and 2 and comma 2 is segment, if this could come inside this segment, that means that this segment is an ancestor, right? Using this logic we are calculating the ancestor. And then we move forward. We are calculating LCA in the same logic using binary lifting. Then we have this part is our segmentary part. Sorry. So how are we calculating the segmentary? This is how are we calculating the lazy segmentary. I would recommend you to watch some TLE blogs or like some online blogs regarding it. It would make it very easier. And then using lazy segmentary, what we are doing is we are performing queries, right? We are updating a segment to a XOR. And what are we storing basically? Let's go step by step, right? So we have this tree, right? We have this tree. Let's say we have this tree 0 1 2 3. We have this array XR, and this array this array. First, we use Leetcode to flatten this array. We got 0, 1, 3, and 2. Using this array, we are creating a new array XR, right? And we are performing all segmentary queries or lazy segmentary queries to this XR. And this XR gives us the XOR from root to a particular index. Root to index. Right. And using this XOR, we could easily calculate queries, right? Because the queries, we need to just calculate XOR of a path. XOR of path can easily be calculated using this formula, right? Going step by step by step. This was the last step that we first calculated XOR from root to each value. And then what we did was using lazy first we converted the tree to using Euler tool. We flattened the tree, and in this tree we calculated the XR. We got the XR array, and then we are doing all the queries and updates to this array using lazy segment tree, right? to get a answer. Also, let's actually see a main function here. So here we are first initializing the end time as well as the length of the total number of nodes we have, right? So here we are also basically this v is basically our tree. This up is basically used in our binary uplifting. This tells us the 2 to the power ith parent of a node. This lazy is basically calculating the lazy value of the node. This tree is basically our tree. This tree is our segment tree that we have applied to the XOR path to calculate the XR, right? From the XOR from root to the node. And this val.resize is basically gives us the value that is present at each node, right? So first we calculated the tree here. This V is our tree. Then we calculated the DFS. This basically does all the pre-calculations for us. Someone commented why you are taking so long, dude. Actually, this particular question is actually consist of too many concepts, right? So I'm just giving a brief of all the concepts I'm going on. Also, like today my system was crashing a lot. So yeah, I like the way you are teaching. Thanks a lot, dude. Take your time. Yeah, it's just we have finished it, right? We are just at the ending. So yeah, again, yeah. If you think you have any like feedback, you could ping it out to me. You can reach out to me in LinkedIn or whatever if you think. So yeah, I'm always open for constructive feedback. But yeah, so here what we are doing is we are updating our in and out time as well as we are updating our value, right? So here we are actually building the segment tree. Now this answer is basically a array of this is a boolean array that we are going to return. Now for each query, what we are doing, we are using string stream to, like, I think you guys have noticed they did the queries in a strange way, right? They give this string to us, right? So to extract each word in the string, what we could do is we could use string stream here. If you're not aware of string stream, you can actually check out some blog or something related to it. Whenever we are given this type of string, then we need to extract it because we could use string stream here. This first basically tells us the first part of the string, this part. So if it's update, that means we need to update it. So what we do it if it's update, we basically update it in our segment tree. And what if it's not update? Then again, remember our formula? How are we going to get a path from XOR from part U to V? First, we get the XOR from path 1 to the path, right? And then this query gives us XOR from path, the path number 1 to that particular path. Then we got XOR to the path uh, from root uh, to that part, and then we got XOR of its LCA, right? This is how we calculate XOR of the path. And then at finally we check how many set bits it's have, right? If it has only one set bit, then only our answer is going to work, right? If it has one or less than one, right? Mostly it could PCDs are completed. Yeah, I think yeah we should just like I should just explain the surface level, right? I shouldn't have explained this deep, I think. Even like I could go even more deep because there are a lot of concepts here, right? So this is like when you will get the submission, I will add more comments to it actually, right? Because the query is calculated pretty in a complicating way. I will simplify it. Anyways, yeah, then we pushed our answer and then we returned it, right? If you have guys have any comment, you can guys have any question, you can actually comment it out. Yeah, it's way simpler if you know HLD, but HLD is actually a very good concept, right? It's very high level concept too, right? Yeah, you can apply it HLD too, but yeah, this also works. Lazy segment tree plus Euler two plus binary Lifton to calculate the LCA, right? Any other doubt, guys? So yeah, this actually calculates from 1 to the in time of u, right? This calculates from 1 to the, this is just a way to calculate, right? I will simplify it if you don't get it, but yeah, this was the entire question. The concept remains the same. The implementation can be treated like, we can do implementation in many ways, right? You can use HLD or we could use, so if you guys still have any doubts, you can actually ping it out and in the comment section. I'll be actively watching the comment section. Got it. So let's end the stream.